Assalamu alaikum. Today is our fifth lecture for digital and logic design. So we can also say it is the part 2 of combination logic circuits or combination logics, which we studied in our previous chapter. In previous chapter we know about the combination logics, combination circuits, difference between combination logics and sequential circuits, applications of combination logics, and how we drive a K-map from a truth table, and how we drive a logic diagram from K-map. So in this lecture we'll study about the design steps for the combination circuits. So let's start. Design steps for the combination circuits. So the first rule is observe the problem definition. For example, you are given a problem to design a combinational circuit. So the first thing you need to do is to observe the problem clearly. Clearly understand the problem. If you will not read the problem clearly, then it will be difficult for you to understand that how many gates you need, how many inputs you need, how many outputs you need. So the first step should be observe the problem clearly. So what is the second step? Determine the required input and output variables. After observing the problem, then we need to know how many inputs are required and how many outputs we need to consider. Why we need this? Because in combinational circuit, the most important thing and the only thing is inputs and outputs. Outputs always depend upon the given inputs, because we don't have any memory unit, so we don't need the outputs of the previous system or previous procedure. So inputs and outputs are very important. So after reading the statement or problem, we need to know how many inputs we need and how many outputs we need. The third step is assign the letter or symbol for the input variable. What this mean? This mean, for example, we know that our problem needs 2 inputs and our problem need 1 output. So we have to assign a specific number, letter or a symbol to our inputs and also output. For example, we can give A input, B input, Y output, like this. We have to assign any symbol or letter to our inputs and output. What is the fourth step? Make truth table that defines the required relationship. So what is the need for this? Whatever relationship is stated in the problem, to satisfy that relationship, we need to make a truth table. The truth table must satisfy the relation given in the problem. So you already know, everyone, how we make the truth table. So first of all, we may in the fourth step we will make the truth table for our problem. What is the fifth step? Determine the simplified boolean expression using K-map. Draw the K-map for the truth table. In fourth step we make the truth table, and in the fifth step we'll make the K-map for the given truth table. So that's why yesterday I give you a brief about how we'll make the K-map from the truth table. So the last step will be draw the logic diagram. Yesterday we also did some exercise about how we make the how we draw the logical diagram from K-maps. So there are total 6 steps which we need to know before drawing any logical circuit. So now let's start with the problem. So this is the problem. Design a combinational circuit with 2 inputs which produce output as a logic 0 when any one input is 1. Okay, Now we will do this step by step. First step is understand the problem statement. So let's read the problem statement. Design a combinational circuit with two inputs which produce output as logic 0 when any one input is 1. So from the statement we know that there are some inputs, and from those inputs we need a specific output. We need a specific output with a special condition. So our first step is complete. What is the second step? How many variables are required? Okay, we'll read the statement again. Design a combinational circuit with two inputs. So from this we know we need two inputs which produce output as a logic 0. This means we need just one output. So our second step is complete. How many variables we need? We need two inputs and we need one output. Now the third step, assign letter or symbol. As from the previous step we know that we need two inputs and one output, so we'll name those two inputs A and B and we'll name the output as Y. So our step 3 is completed. Design a combinational circuit with two inputs which produce output as logic 0 when any one input is 1. So we'll make the truth table. So we will make the truth table in the fourth step. A, B and Y. A and B are the inputs. So as we know, how many possibilities will be there for the two inputs? There will be 4. I think we already know the formula for this. 2 to the power n, and what is n? It's 2, so it's 4. We have 4 output possibilities. So this is the truth table we draw: 0 0 0 1 1 0 1 1 1. What will be the output? The output according to our procedure is output as logic 0 when any one input is 1. So from these two inputs, if one input is 1, then the output should be 0. So first of all we take here one input is there, so the output is 0. Here one input, so output is 0. Here 1 1, so output is 0. So there are 3 outputs, 0 outputs, and here there is no one input, so the output will be 1. So this is how we draw the truth table. Now the next is make the K-map of from the truth table. How we make the K-map from truth table? I think in last lecture I also teach you. How many variables we have? 2 variables. So 2 variable K-map is drawn here, A and B. So from this table we'll draw this 0 0 1 0 1 0 1 0 0 and 1 1 0. So from this we mark here 0 0 1 and rest others are 0. So how we'll make the equation for this? We'll make, because SOP form, so we'll take only one, and the equation will be for this is A bar into B bar. So this step is finalized. So now we have the final step, draw the logic gates. So logic gates, let's see what output we need. We need A complement, B complement. So this means we need product. So whenever we need a product, we make use of AND gate. But our input is A and B, So how we will make the A complement and B complement? By using NOT gate. So we take two NOT gates. So the output of NOT gates was A complement and B complement, and for AND gate the final output will be same as our K map, A complement into B complement. So this is how we solve our combinational logic circuit in 6 steps. I think you all understand this, but still if you have any issue or problem, you can contact me about this. Thank you for today's lecture.